Today, we're tackling random forest, one of the most powerful and fascinating algorithms in machine learning. If you saw our decision tree video, you know those trees can be a bit like overconfident know-it-alls, fitting the data a little too perfectly. Well, random forest is here to fix that. Imagine you're lost in a forest, not a creepy one, but a friendly one where a bunch of wise trees team up to guide you home. That's random forest in a nutshell. A bunch of decision trees working together to make smarter, more reliable predictions. Stick around because we're going to break it down with examples, code, and accuracy test. Let's make this easy to grasp. Picture this. It's movie night, and you and your friends are trying to pick a flick. You've got one friend obsessed with action movies, another who only cares about the lead actor, and a third who's all about the director's vibe. Each friend suggests a movie based on their own quirky criteria, and then you vote. The movie with the most votes wins. That's how random forest works. Each decision tree in the forest is like one of your friends looking at the data in its own unique way. And the final prediction comes from combining all their votes. It's democracy meets machine learning. Pretty cool, right? So, how does this forest grow? Random forest is an ensemble method, meaning it combines multiple decision trees to get a better result than any single tree could on its own. Here's the magic in 3 steps. We don't just give all the data to every tree. Instead, we create random subsets of the data by sampling with replacement. Imagine you've got a bag of 100 marbles, and you pull out 100 with your eyes closed. Some marbles might get picked twice, and some might stay in the bag. Each tree trains on its own weird little subset, which keeps things diverse. In the second step, when each tree makes a split, like deciding action or comedy, it doesn't look at all the features. We randomly pick a handful of features to consider at each step. So one tree might care about petal length and width, while another focuses on sepal size. This randomness stops the trees from all thinking the same way. Lastly, when every tree is trained, they vote. For classification, it's majority rules. If most trees say species A, that's the winner. For regression, we average their predictions. And here's the kicker. This teamwork fixes the decision tree's dark secret. While a single tree might overfit and get cocky, random forest smooths things out, making predictions that generalize way better to new data. Let's see random forest in action with the iris dataset, that classic flower classification problem. We've got measurements like petal length and width for 3 species of iris flowers, and we want to predict the species. Want to try this yourself? Here's how to whip up a random forest in Python using scikit-learn. First, we import the essentials. This iris is the best dataset to use while learning or experimenting with classification problems. Importing accuracy score for model accuracy mastering. Next, load the iris dataset. First, we split the data into training and testing sets. Then we build a random forest with, say, 100 trees. This n estimators is the number of trees we want to create inside our algorithm. Each tree trains on a random chunk of the data and picks random features to split on. Finally, predict and check the accuracy. Boom. In a few lines, you've got a forest classifying flowers like a pro. So, why should you care about random forest? First, it's a lifesaver against overfitting. Those individual trees might get too attached to the training data, but the forest averages out their mistakes. Second, it's a beast with big data sets, handling thousands of features without breaking a sweat. Third, it tells you which features matter most. Super handy for figuring out what drives your predictions. And it's everywhere. Banks use it to spot fraud, doctors use it to diagnose patients, and even Netflix uses similar tricks to recommend your next binge. There you go. Random forest, unpacked. Thanks for sticking around. See you in the next one.